So I'm Diane Greene, and I lead cloud at Google. And I'm also on a few boards, and one of them, the Alphabet, and also MIT, which I think is why I'm here, because Google has some real AI experts. I don't happen to be one of them. But we have Fei Li leading the cloud machine learning. We have Jeff Dean, who did Big Table, BigQuery, Spanner, and now does AI, leading Google Brain. And then we have Dennis Hassablis at DeepMind. That's the group, Alphabet company, that won AlphaGo, beat the 9 Dan world champion at Go. But I'll try and talk about what we're doing here. Maybe at a higher level than they would. You know, AI's been, you know, back in the 60s, people had this vision that maybe you could teach computers to teach themselves through observation. And really, a lot of the algorithms we're running today were done back in the 80s and 90s. And as we all know, what's really changed is processors are like 1,000 times more powerful now, and data storage is really cheap. And you had things like Fei Li's ImageNet, where you had this huge corpus of labeled images, so machine learners could test their algorithms, you know, and really make advancements. And so it's you know, when you put all this data together in the cloud and you join it with other data and you train on it in this phenomenal compute power, specialized processors, that's why all of a sudden we have a revolution going on, you know, that's going to really change a lot of how we live. And you know, I'm an optimist. I think it's pretty clearly for the better. Data, you know, it used to be really pretty much text and numbers, and now, you know, 90% of the world's enterprise data, probably more if you add in consumer, is unstructured. You know, it's video, it's speech, it's images, and so forth. And you know, what machine learning is doing is kind of giving some structure to all this data so we can really do useful things with it. And we've got a number of APIs Google's developed to help people in their applications easily take advantage of it, things that can recognize speech, do natural language processing, recognize images, do translation in real time to other languages, just transformative for our world, even a jobs API for finding jobs. And and then, you know, there's the whole other set of things that a cloud gives you with all the tools. Google's, you know, been doing cloud, been doing AI for pretty much all 17 of its years, and I'll just quickly tell you a little bit about some of the things we're doing for the community. A couple weeks ago, we announced that we had acquired Kaggle, a company we got from the top sponsor of this conference, Zeta Venture Partners, thank you. And they're going to remain Kaggle, but what they are is the world's largest community of data scientists and machine learning people, and they're kind of known for running competitions around you know, testing out machine learning, but what they really are is a way to share large data sets, to share models, and we think it's just going to speed things up even further. We're really excited to get to work so closely with them, and in conjunction with all the strengths we have on our cloud, but broadly, they'll, you know, stay Kaggle. And then also, you've probably heard of Tensorflow, one of the something that Google developed, and that's what DeepMind used for AlphaGo. We then used the same kind of similar models applied to, we actually can save about up to 40% energy in our data centers using a data model we built with that. But anyhow, TensorFlow has sort of exceeded our wildest expectations in its popularity, and you know, we're moving that forward. We just released a new release that's easier to use, more user-friendly, part of this democratizing AI, making it really easy to use. You know, it supports other algorithms and a lot of performance and scaling improvements, because the more data you can learn on, the better the accuracy, of course. And we also have developed, and this is something you'll increasingly see in the industry, is specialized processors. So we have something we call a tensor processor unit that can give you up to an order of magnitude performance improvements, lets you train bigger data sets faster, and there'll be ongoing, you know, that's what Google uses today for search. We use it for Smart Reply, we use it for the calendar, we use it for Explore in Google G Suite, we use it in YouTube extensively, etc. And we're bringing it to our users. Now, this one is really my favorite use of TensorFlow. TensorFlow is something you can run on your laptop if you want to. You know, it's open source. And there's this family of farmers in Japan, and I guess the son, you know, came home from school and watched the backbreaking labor that his parents were doing, and he set up they have a cucumber farm. He set up a camera and did a TensorFlow application to look at the cucumbers and sort them by quality and size. And it saves his parents several days every harvest now. Something we recently introduced was Video Intelligence API. You know, something like YouTube is doing hundreds of hours of video every minute. You know, enterprises just have hours and hours of video, and humans can't, you know, it's too hard to find anything. And what this does is automatically label all the images and let you search them. And I wish I had time to show you a really amazing demo on that. We're really enjoying taking all this to every kind of vertical industry out there. It's really exciting. Retail's just getting completely transformed, getting very frictionless with understanding your customers and doing automated delivery through self-driving cars, through drones, just-in-time shipping, optimizing the product mix by store, you know, and endless things we're finding to do. Financial services, which is really quite data-intensive industry, helping machine learning being used to do, you know, pretty clerical tasks, detecting things like money laundering, any kind of risk analysis, fraud detection, identity theft, and even interacting directly with the users of a financial system using natural language processing, so you have a nice interface, up-leveling the whole experience with banking. Just seemingly endless opportunities there. Manufacturing, another gigantic area. Of course, there's robotics. There's also this particular example, little startup just doing amazing things in plastics, an assembly line where they're using Raspberry Pi to monitor each part, and then take all this data, and they've machine learned on it, and then it can give the workers notifications about things they should be paying attention to, so it can take fairly unskilled workers and really elevate the quality of what they can do, and also take a lot of the drudgery out of their work. Again, lots and lots to do in the world of IoT and manufacturing. Here's an example in aerospace. Airbus does satellite images. They had lots of people, trying to clean up these images, trying to differentiate snow from clouds, and the humans actually couldn't do it. We helped them do specialized image detection on their satellite images, and it can be done much more quickly, and of course, but also much more accurately. You take a company like Planet Labs, they have, more satellites up in the sky, small satellites taking pictures of the world every 3 hours, the entire world at sort of 30-centimeter resolution. Lots of things to do for agriculture, climate change, hedge funds, you name it, there. So I, too, was going to talk about diabetic retinopathy. I won't say much. That was a paper Google published with Stanford. It's one of the fastest growing causes of blindness, and if you catch it early, you can prevent the blindness. The doctors, the ophthalmologists actually rate things from 1 to 5, and it turns out there's 60% accuracy there, and if you ask them a few hours later, there's only 65% agreement amongst what a given doctor predicted. And this is beating what a doctor can do. And what this means is now you can do this diagnosis with an inexpensive camera anywhere in the world and, catch it early and prevent blindness. The same thing with tumors, with dermatology, taking medical records and predicting outcomes, real-time monitoring. There's something DeepMind's running a trial right now where they're actually able to they've already saved lives through early detection of a certain kind of liver disease that is really the product of using machine learning. So, there's been a lot of hype around machine learning. The reason is every company is kind of building a virtual rendition of itself in the cloud. Some of the, if you think about it, machine learning, you train a model and then the more data it sees, the smarter it gets. And it just is there forever. I mean, we humans have a pretty imperfect way of transferring our knowledge, and when we die, we lose a lot of it. But, there it is in the model, forevermore, getting smarter and smarter all the time. It's a very exciting advancement that's, improving how we live and changing, what every industry does. And, yes, you'll have processors out in the devices, processing data, doing machine learning, reducing the amount of data, and then bringing it up to the cloud, where you can join all the data and do even more powerful insights and actionable notifications on what's going on. I mean, ultimately, industries will build little applications for their business that calls APIs that help them use machine learning, that also real-time processes their data to make decisions and really communicate well with customers or manage their assembly line, what have you, and the cloud's going to do all the rest. And so I think it's sort of a renaissance right now. We're really at the beginning, not even at the first inning. And it's pretty exciting to think about, just in the short term, some of the kinds of queries we'll be able to do. Which of these eye images shows symptoms of diabetic retinopathy? That's a query you could ask. Describe this video in Spanish. Find me the documents related to reinforcement learning for robotics and summarize them in German. These are the kind of queries, machine learning is letting us do. And, I'm sure there's all kinds of things we can't even imagine that we're going to be able to do as we increasingly get this data under, and apply these new techniques to it. So, you know, I feel pretty lucky to be part of this, really enjoying it. And thank you very much.